Hey, welcome to the stream. I'm Jared. You can call me Jardo if you want. And today we're doing Advent of Code, day 12. Hey, Marco. So let's get into it. Oh, why is it showing that? That is not what's... Something's busted. Uh-oh. What you're seeing is not what's showing in my browser right now, which makes me think something's like frozen up or something. Just gonna try and... There we go. That actually working? There we go. Cool. Okay. Great. All right. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant. It is indicated by a single letter on your map. When multiple garden plots are growing the same type of plants and are touching, horizontally or vertically, they form a region. For example, okay, that's a region. This 4x4 arrangement includes garden plots growing 5 different types of plants, labeled A, B, C, D, and E, each grouped into their own region. So we have plots and regions. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, C plants are each in a region of area 4. The type E plants are in a region of area 3, and the type D plants are in a region of area 1. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. So let me read that again. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with perimeter 10. A and C. How is that 10? Oh. Oh, no, I understand. Right. Okay, so that makes sense. So like A has, can we select? A has 4 sides on the top, 4 sides on the bottom, and 1 on each side. C has 1. This has 3. 2 makes 5. 2 more makes 7. 3 more makes 10. Okay, that makes sense. Type E plants in the region, area 3, and D plants are in a region of area. Wait. Oh, that's the area. Plus perimeter. Yeah, perimeter 4. Okay, yeah, so we're good. We're good. Visually indicating the sides of plots in each region that contribute to the perimeter. Okay, so they've done that out for us. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, sure, irregular regions. The above map contains 5 regions, one containing all of the 0 garden plots, the other 4 each containing a single X plot. The 4 X regions each have area 1 and perimeter 4. The region containing 21 of the 0 plants is more complicated. In addition to its outer edge contributing to a perimeter of 20, the boundary within each X region contributes to an additional 4 to its perimeter for a total perimeter of 36. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for each region on the map. The first example, region A had, okay, so it's going to go into examples, some larger examples. I don't know if I want to read all of those out. What is the total price of fencing all regions on your map? Well, that's a lot. All right. Significantly more complex input than yesterday. Is this thing a square? 141, 141, yes. So this is a square, size 140. But we probably don't want to assume that just for the sake of testing inputs and stuff. Had a nice early 9:30 hockey game last night. I was also playing 3 tiers below where my regular team plays, so I scored my first hat trick. I hit the gym this morning, so I'm feeling good here. Let's do my gut is we iterate over this thing. Through each cell, we mark the cells as visited when we visit them, and we keep looking at all the like we look at the adjacent cells, add them to like a queue or something, and once we have run out of cells, then we count the region and then continue iterating through the actual cells in the map. Skipping them if they have been visited already till we hit another new region, do our little algorithm to count out that region, and then continue on. That sounds like a reasonable approach to me. Righty, so let's use matrix again. Just because it's fun to use things we don't normally use. And, you know, we got this thing, so I guess we should parse this thing out. Read lines, chomp true, map chars, and then it could, yeah. wait a second. We got to eval this input. Right? We can do this. We can do this. All right. It's not the most interesting one to eval, but if it can be evaled, it shall be evaled. So kill this. Kill what I was doing. Kill. We just kill read lines. I mean, it's valid Ruby, isn't it? Isn't this just going to be a bunch of like const missings? Maybe we'll find out right now. Every line will const missing, and then we can deal with that. Okay. Uninitialized constant. So I have never used const missing. Const missing. Whoop. Oh, I see. That could be why my thing messed up earlier. On my regular user, I updated Firefox. Just takes the name. Cool. Name. So let's just puts them. Oh, that doesn't work. Oh, it's got to return a constant name as a symbol. It doesn't look like it was actually working at all, though. It doesn't look like it was getting called. Oh, there we go. Okay, amazing. So this will just load. We'll just use this to load. It won't actually solve the problem. Or should it? I think we can make it do it. As long as our inputs are always square. If size nil, size equals name.length. Hopefully this is a string. It might be a symbol. And then we also need to set up our map. Which will be a matrix of some size. Let's just remind ourselves how to build this, a matrix of arbitrary size. Create a matrix for each, no, not you, build row count, column count. And it's square, so we can just do new, build size. And do we need to pass it a block? Turns in a numerator if no block is given. Okay, no, I don't want that. There we go. Okay, so our result is going to be a val input, because at the end we're going to say something. You have to keep a counter here, like current row equals 0, and then we want to say like if current row equals size minus 1, to say, or I guess it'll be size at this point because I'm going to increment it. Then return the solution. All right, so this should, oh, I missed that. Whoop. Did not, oh, it doesn't return, evaling this doesn't return anything. Well, I guess we can just do that. We can just print the solution. Oh, this isn't getting there. Current row equals, oh, and that's funny. This would be current row. It's going, what's wrong? Oh, I'm not calling eval on the input. Okay, so that prints this is the solution. And just to double check, okay, so now I can't, okay, this is good. There we go. So we do get the solution out. I knew we'd be able to eval an input eventually, even if it wasn't like a more exciting, actually interesting chunk of Ruby. Okay. Now I need to load the data in. So I think, is there a row equals on these things? Row, doesn't look like it. Oh, but I can set row? Is there a set row? What can I do with rows? Cofactor? No. Each? No. No. No, 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 no. Okay, guess not. Can I manipulate? I guess I don't even, I'm overthinking this because I can do, so name.chars.each do, and then, or sorry, each with index, and I'm setting map. Current, or x current row to be equal to C. And we'll probably want to introduce an actual object that I can mark as visited or something, and actually do something interesting here. But for now, that'll do. Okay, and as I expected, we need to convert that to a string. And instead of doing this, let's return, I don't know, map for now, just to see that we're loading a bunch of strings into this thing. It's beautiful. I do wish there was a better, that it like represented these in a way that was a little easier to look at. Okay. Thank you, Marco, for recommending using matrices at some point. I am feeling more comfortable with their API rather than just like thinking through. So I guess this only works because it's uppercase. Well, we could use method missing if it was lowercase. As long as they were some kind of valid Ruby token that I can hijack. All right, so we're going to need a new object called, what do we call them? I want to make sure I use the same words. Area version of plot. Class plot. And we call them plants. And so now we want to set these to a new plant. And I actually think we want to bring back, did I not commit this? Why is this changed? And I think it's day 10, not day 10, where we refined matrix to not support negative indexes anymore, because we don't want to use negative indexes. It's easier for us to just get nils when we go off the edges of the map. This logic won't work anymore though. That was our change to how they appear when we inspect them, but that was specific to the puzzle. We could still use that later if we need to for debugging. We'll just have to modify it for the types of values that are in our matrix. Okay, so this should still work, and we should still get, there we go. Stack level 2 deep in const missing. That's interesting. And somewhat troubling. Stack level 2 deep. Something else must have hit const missing, and maybe we can bail out super, or maybe we can put this in the refinements. Let's try both of those options. So super if name.2s.all. Can we just do uppercase? Is that a thing? Oh, 2s.chars.all. Define method uppercase. Ruby check if character uppercase. Regex. Fine. Oh no, unless, there we go. Uninitialized constant plant. What did I? Oh, I said, nah. Okay. And typos galore. Okay, so that works. But let's just change this back to plant and see if we can move. No, I don't think we can. I was going to say try and use refinements, but I don't think that would work. Okay, so now we only catch const missings that are probably the result of this input. If any other all uppercase constants get const missing, well, we're still screwed, but you know, we're only writing extremely serious production code here. So now that we've done this, kind of want to know each with index do, and we're going to do something in here. Plot, is it XY? Is this how we get their values? We do have a plot, and we have an X, and we have a Y. And the next thing I want to know is, what order are we iterating? Is it rows first? No. Can we tell it to do that? I guess that doesn't actually matter. My algorithm doesn't care. I don't know why I thought it did. I just intuitively, that was what I was expecting. Okay. So we need a little API on this thing. For the sake of our object shapes, we'll even assign it in our constructor in a deterministic order. If anyone's watching this who hasn't heard about the whole object shapes thing, I think at least Aaron Patterson has talked about it in conference talks. Yeah, there we go. RubyConf 2022. Maybe. And he's apparently done some pairing and stuff on it. And my upstairs neighbor's pipe is leaking onto the roof of my sunroof again. All right, back to the puzzle, but interesting stuff to check out. I don't think it'll make a significant performance difference to the code we're writing here, but it's just kind of good practice in the absence of anything else. So for each of these, we want to next if the plot is marked. And then we want to look at the how do we do this? We look at the current plot, and we want to look at the cells around it, or sorry, the plots around it, and check if they are, if it's a border, right? So we can say plot.mark. We visited this one. And we're going to have some nested loops here. I'm not thinking about that at this moment. We're going to probably use a stack of some kind. Again, not thinking about that yet. Just, only got so much brain power. I'm on day 3 of cutting out coffee. So at least my head doesn't hurt too much today. We're going to iterate over the adjacent tiles, which are x plus 1, y. Whoops. I'll figure out how to type eventually. X minus 1, y, x, y plus 1, and x, y minus 1. And we want to sum up I guess we can shadow them. We don't need the original coordinates in here. Sorry. Excuse me. And we want to sum up or I guess we're just counting. We're not summing. Okay, the edges. So we want x. We want to check map x y dot plant does not equal plot dot plant. And we have to use that because we might go off the edges of the map. But that's fine. Nil won't be equal to our plant, so that's fine. Then we have to do something with this. I guess we're actually summing here, right? To get the result. So in this case, we have encountered a plot that we need to count. And we're going to make a stack. And can I use it? I was just thinking about, is there like can I do like kind of like set operations in, I kind of just want to be able to like pop them out of here. I mean, I can delete them. Just to avoid getting multiple. I guess it probably doesn't matter. I'll worry about that if it's a problem. So plots becomes just our single plot, and then we're going to loop until oh, but our plots don't know their XY coordinates. That's tricky. Do they need to? Yeah, I think they need to. It's really awkward to write this if they don't. Okay, well, we'll write the code we want and make sure that that's true. And then, excuse me, and then we'll see what happens. Man, I'm still getting so much spam on my contact form on my website. So until plots.empty, we want to plots dot pop. Plot equals plot dot pop. So we're shadowing. I don't care. And map is actually at map. Plots. Border perimeter count. How do we want to talk about this? What do we try? Which is it's plot time multiplying a region's area by its perimeter. So we need to calculate area and perimeter. And so for each of these, I'm going to say, okay, we increase the area by 1. We'll do the marking in here, because down here we want to return the area times the perimeter. Area is plus equal to 1, and the perimeter is that. And we want to, as we're going, I guess we don't need to. I'm going to extract this to a variable because we're going to reuse it. Or that's not, no, I can't do that. I can extract it to a variable. I was going to extract it to a constant, but I can't. Adjacent tiles. Or I don't even know what to call this. Adjacent coordinates. It's not a great name, but. So we add that, and then with we also want to loop over the adjacent coordinates. I don't know why I keep getting weird syntax stuff. And we want to, if map, or unless map xy is already marked, or plots dot include, okay, I'm just going to plot equals at map xy, plots dot include plot. So unless we've already counted this plot, this adjacent plot, or we've already put it in our queue of plots to check, then we want to push it on there. And then we're done. Now, these coordinates are only valid because on the first one, because they're coming from here, we need to actually get them from the plots themselves. So that's fine. We did confirm that. All right, x, y, and add those here and pass them in here as x and current row. And then we need to update these. So this becomes plot.x. Actually, let's just get all of these at once. Oh. There we go. In fact, this is way too long of a line. We don't like long lines around here. All right. I don't think these xy's are coming from these, so that's fine. So I think that's vaguely. I mean, I don't know. Maybe that works. All right. Got to handle the nil case. And plus, adding to nil can't be coerced into integer. Inside of matrix, where is this called from our code? Day 12, how would it be 63? 63 is here. This is our return value, right? Be coerced into an integer. Why would we have a nil ever? Oh, ha 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 ha. Right here, right there. Okay. I mean, it produced a number. Maybe it's the right number. Number is too high. That's interesting. Well, what have we done wrong? I'm just gonna make this an early return. There we go. It's area times perimeter, right? So this should visit a plot. Say, okay, we've got a plot. Mark it. Increase our area. Count the adjacent tiles that add to the perimeter. Iterate over those adjacent tiles. We can combine this logic. We don't really need to do 2 iterations. Unless plots nil, are already marked, are already in our list of plots, then we push it. And then set plot.nil, or then we can skip the double iteration. Then we return to this original sum, or area times perimeter. And we're looking for area times perimeter. Let's just double check. The second example, the region of all is okay. What is the total price of fencing all regions in your map? Yeah, and that's multiplying a region's area by its perimeter. Okay, well, let's try for some smaller ones and debug, I guess. Oops, I guess I should run it. Make sure we still get the same result that we got. No, we get a different number. Well, that's interesting. That's a smaller number. I wonder what bug I fixed. If that's the right answer. No, still too high. That refactor somehow just want to double check. Make sure I did that logic right. Yeah, so this is only happening once. So what input do we want to test on? Let's test on maybe the simplest input because we can kind of do the math for it pretty easy. Just gonna make sure, yeah, it is square. So this one runs, we get 256, and we can manually do this one. So A, B, I might have it in there, but I just want to sort of walk through the logic. The perimeter of A is 10, and the area is 4. The perimeter of C is also 10, and the area is also 4. The perimeter of B is 1, 2, 3, 4, 5, 6, 7, 8, and the area is 4. Perimeter of D is 4, and the area is 1. And the perimeter of E is 6, 7, 8, and the 3. So 24, 4, 40, 32, 40, and 40 plus 32 plus 40 plus 4 plus 24 is 140. Well, that confirms that didn't work right. Do they talk about? Interesting. Okay. But now that we've broken this all down, I'm just going to pull this out of here because avoid causing issues with our input. Let's put it here and comment it out. We can now print some information as we go. Oh, hello. Plot.push. We don't check to see that this is even a correct. We do need the plot. So this needs to. How do I? There's a. Oh, geez. I don't know how to use my editor. I'm a Vim user. I'm just trying things now. I want to like select all. Anyway, okay, I'm not going to bother. So this is plot. This is adjacent plot. And we have new cases. This is getting really long, so I'm going to. Probably kill this case and just use these and or adjacent plot dot just C. does not equal plot.c. If it's not the same, if I would say include, for instance, a plot. This I updated the wrong one. And that needs to be and it's plant, it's not C. Where did I get C from? Must have used it somewhere else. And and I deleted the area times perimeter down here at some point. Well, that's funny. That logic can't be right. My dog is snoring. Probably can't hear it on the mic, but she is curled up in her bed and she is snoring to the sounds of me. Oh, she says she's dreaming, actually. Little paw wiggles while she's there. I don't have the ability to rotate the camera, but she looks something like this, but asleep. Got a tattoo of her at some point. All right. I just want to know if we ever hit this. It kind of feels like we're not. Oh no, we are sometimes. This is false when it's... How are we getting 0? Like, this is like the perimeter, like this is always returning false. Oh, it is always. We didn't update this variable. Well, now we have a new incorrect answer. Which sucks. JSON plot.plant does not equal. Can't be right either. Always false, always true. I don't follow you. So we want to push. We want to push new plots onto our stack if the if they're the same kind of plant here. If we haven't marked them and they're not already in the list, and plot let me see here. $91. Yeah, sorry. Oh, thank you. Oh, yeah, that's bad. That's a silly mistake. Thank you. And now we have the right answer. Thank you, Marco. I just got a little too copy paste heavy there. So we can work back. So now we know this produces a right result for our test input. So let's see if we just walk all the way back to our real input, whether it provides a correct result. This number I think is smaller than the other ones we've tried, so that's a good sign. It is, yeah. And it's not just that, but it is right. All right. So let's just get rid of that quickly. I should turn that off since I really only use Vim for writing commit messages now. All right, thank you, Marco, for pointing that one out. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence, oh, this is so annoying to do. Each straight section of fence counts as a side, regardless of how long it is. Consider this example again. The region containing type A plants has 4 sides, as does each region containing plants of type B, D, E. However, more complex regions containing the plants of type C has 8 sides. Using the new method of calculating per region price by multiplying the regions, we get a total price of 80. For the second example, okay, it gives us more examples. There's a joke about Mobius strips. All right. I actually don't have a really good intuition on how to even do that. How do we do that? I feel like we're going to need to use an approach where we gather up the plots to get, like, so that we can just iterate over the plots. I can imagine solutions where we, for each direction, up, down, left, right, we, for example, say we're looking for left sides. We would then iterate, we would start at the leftmost column of plots in the region, we would then iterate downwards, and when we hit one, we would sort of like chunk that until we hit a blank or a tile that's not that breaks the wall. I think we can do that. That's really annoying. But it's definitely doable. I'm just gonna go grab a cookie. Keep me fueled up here before we get into this one. So I have to refactor this one. I think I'm gonna refactor this to pull out the plots and operate on the plots, and then I'll have sort of a second way that I can then that I can count. And I think we should be able to just sort of output both the part 1 and part 2 just with different counting methods, I think. So I'm gonna do that, but first I'm gonna eat a cookie. All right. Let's do this. Did commit. Okay, so we're going to want to create a list of regions. A region is just going to be a set of a set of a region is going to be a set of plots. That's going to simplify this logic here. So that'll be kind of nice. So let's go. We're going to start similar logic here, but we're not summing. Whoop. So I don't know what I keep doing there. Is it that? No. I don't know. I'll figure it out eventually. We're not summing anymore. And create a region. It was a Scandinavian almond cookie. It was very good. And we can just immediately add this region to our list of regions, and then we'll put all the stuff in it. Excuse me. So we basically want to do the same thing here. Plots equals plot, and then until plot's empty, we're going to loop over and mark them. but we don't care about area. We do care about adjacent coordinates. We don't care about perimeter, but we do care about the logic of adding wrong thing. So we can even do next if adjacent plot marked, next if adjacent plot nil, next if region already has this plot, or no, plots already has this plot. That's fine. If region has the plot's marked. Next if that, otherwise we push it. Cool. And we need to add it to the region. Okay. So we've basically recreated this logic. And then this, I'm just going to comment this out for a sec while we work on this. Now we can say regions.sum, and a region is a series of these things, and we do perimeter equals region dot sum plots. We need to reuse our adjacent coordinate thing here. I guess we don't need to, no point in having it in a variable if we're not reusing it. And then this, we're counting the adjacent plots. Right, we have to do the logic. We are counting this the adjacent. I keep pausing to let the AI integration help me out, and then remembering that it's not turned on, which is good. I don't want it on for these puzzles. I just keep forgetting that that's the case. So our logic is there. Adjacent plot. Love that. And so now it's an area. Just for explicitness, we'll say area equals region dot size, and perimeter, return perimeter times area. And see if that gets us the right results. Oh, not get commit. Was that the same result as before? It was. Okay, cool. So that refactoring worked. We can get rid of this. And I'm going to remove even the puts. I'm going to say part 1 equals, and I'm going to say puts part 1 here. Can I just like assert part 1 equals what are it supposed to be? Not that. I use a clipboard manager on my real account. Undefined method assert now. Too bad. Okay, just in case we break anything. And now we can do part 2, which is very similar in that like we're going to be summing the regions and the area is still going to be the size. In fact, we can even just move this up to the top so that they're consistent, and this will be sides times area, and then we just have to write sides equals something and do a similar. Now, so we've done all of the easy stuff. Now we just have to do the hard part. How do you mean area? Oh, I put it in the wrong spot. Cool. All right. That number that part 2 is printing is just the total number of the total area of this, since we set sides to equal 1. But we want to set sides to equal 0, and then we want to iterate over each row and column within this region. Which I guess means we just need to find the min and max x and y values. Which is not terribly difficult. Min, y, and I guess then we do max x and max y. Oops. A lot of exercise in the last couple days here. I have to not use up all my brain power on this either, because I have a poker game tonight. Looks like 9 or 10 people coming, and I won last week, so I'll try and show up and play good again. My initial run when I started hosting this poker night was a lot of losing, a lot of playing bad. So we're going to iterate from min x to min y, inclusive. Each do, sorry, no, min x to max x. What am I doing? X, and within that we are going to iterate from min y to max y. And I wonder if we can use like some Ruby enumerable stuff like chunk. Why? I don't want API doc. Get out of here. Get out of here. Ruby enumerable. Give me Ruby doc. Give me Ruby doc. I should set it up as a thing I can just search for easily. Chunk and chunk while. Each element in the returned enumerator is a 2-element array consisting of a value returned by the block, an array chunk containing the element for which that value is returned. Okay, let me look at the example. So so maybe chunk while is what we want. I'm trying to think about how we do this. Chunk while creates an enumerable for each chunked elements. The beginnings of the chunks are defined by the block. The method splits each chunk using adjacent elements, element before, element after, in the receiver enumerator. This method split chunks between elt before and elt after, where the block returns false. So we have this array of numbers. And it chunks while the first one plus 1 is equal to the second one. So it chunks 1 and 2 together. Then it chunks 4, and then it chunks 9, 10, 11, 12. Then it chunks 15, 16. I think that's almost what we want. Because we want to... We want to keep chunking them while they're both part of the same side. So like if we have, how do I just draw? If I have, say, just thinking about examples. Yeah, so let's imagine that, and we got more stuff over here. We're not thinking about that. We're iterating down this one. We want to say, okay, so this is a side. Yeah, heck yeah. Which is, you know, we know that this is not another one of this type of plant. It's either an empty tile, i.e. it's the edge of the map, or it's, in this case, some other region. And we want to say that's true of this one too. And then we get, so those go into the same chunk, and then we get to these two, and we say, okay, well, this one's part of the region, but this one has a thing, so stop. But the thing is, we don't want this to be part of a new region. So maybe we have to iterate over these and reject some of them. So let's say we iterate over and we say, okay, this is a possible side. This is a possible side. Not a possible side. Well, geez. Not a possible side. Here, let's switch colors. Not a possible side. Not a possible side. This one's a possible side. This one is not a possible side. I mean, there's nothing there. We wouldn't be iterating over anything. And these two are. And then I guess we just chunk them while they're adjacent, which is basically what this was doing here, where if we pretend that these are the y coordinates in this case, we are just chunking them into the adjacent ones. That works. Good old TL draw coming to the rescue. All right. So I think we just have to implement that algorithm. So we can do that. We can do that because So now we are trying to create a bunch of columns here that we can iterate over, right? So we want to flat map these into and then map these, and then we're just looking at map XY here. Come on, XY. So that gets the cells. That can return nil. Oh, but no, that's not right, because that's going to get the entire region, including, or that's going to get stuff that's not in this region. So we actually just want region dot find. We want to look for a plot where the plots x equals x, and the plots y equals y. And we can compact that because we don't need the nulls in there. And I guess for it to be contiguous, we can't have any empty columns or rows. So each of these are going to have stuff in them. So that's cool. And then we're going to want to do the same for rows. Are we flat mapping? Is that right? No. That's not. This is just map. And we just reverse that, and that's the same. But this time, it'll be a bunch of ordered rows. More looping in order. So everything should be in JSON in ascending order. That's great. That makes this easy. So I'm going to say this is left sides plus right sides plus top sides plus bottom sides. And so we are going to write logic to write to figure out left sides here. Columns dot sum. So each column can contain multiple sides, so we use sum rather than count. And we want to so we want to reject the invalid entries. So this is these are plots where the plot to the, so these are left sides, so the plot to the left is not a or we're rejecting ones where it is the same, it is within the region, right? So we're using plot to the left, so we'll use the map because that's easiest, I think. X minus 1 is left. Plot that x minus 1 could be nil. Dot plant equals plot dot plant. And then we are going to chunk while element 1, element 2, I don't know. Or I guess we can call them plots. Plot 1, plot 2. And we want to check while plot 1 dot y, sorry, yeah, y, we're looking down, is equal to, or plot y plus 1 is equal to plot 2 dot y. And we want the length of that. All right, I'm gonna just right sides equals 0, top sides equals 0, bottom sides equals 0. And we'll see if this actually runs. Obviously it won't produce the correct result. Oh, did I something get moved over? Yes. And it errors because wrong number of arguments given. 1 expecting 2 on day 12, line 8. Line 8? Oh, line 137. 137. We forgot to include the y coordinate here. Length is undefined for an instance of enumerator. That's fine. We can call that size. Nil can't be coerced into an integer. 135. How could this return nil? What is happening? 135, 135, 135, 19. Wait, are returning size? I don't see how that can't ever be null, can it? Well, let's just get our debugger in there and take a look. So we can column.reject plot at map plot.x minus 1 y. This should actually just be the same as the column because we're in the first column, so there aren't going to be any to the left. Then let's try this logic. I'm just going to copy paste it for convenience. And let's make an array out of that, and it should have one element, yeah, because the y elements here are all contiguous. This is something along the left side of the board. In fact, it should be, whoops, it should just be this here, 5 elements right there. So this is the region that we're testing. But if I call size on that, I should get nil. Why? Do I have to convert it to an to an array, I guess? Or count? Count. Count is what I want. Don't know why. There. Okay, so count. That seems to be what I want. That's the one on enumerator. And that produces a number. A totally plausible number. So we can now do the same logic, but for the right sides. And that changes this to a +1. And now we we should get a slightly bigger number. Sure. And then let's do this for top sides, where we are now summing the rows. And we want to look at the what is up, which is -1. And that should give us an even bigger number. And then we want to look down, which is +1. And that is a very possibly correct looking number. Like, I'm not saying it's right, but too high. But it is a result that's like within the realm of possibility here. I don't immediately know why it's wrong either. Trying to like imagine it could be a logic bug, or it could be a, oh, I know why. So we continued checking y here when we should have been checking x. Just would have been chunking things together that shouldn't go together. Okay, we're still in results that are within the realm of possibility. Now our answer is too low. Interesting. How do we debug this? How do you think? It ain't pretty. Yeah, that's fair, Marco. I'd be tempted to. I feel like might have some friends who want to play some video games soon, but I'm also not very good at putting things down. So we got one that was too high, one that was too low. Our top side, we are iterating over the right values. I mean, I feel like maybe we step through here and just take a look at our results, because we can compare them pretty easily with the map, or we can swap over to the old test inputs. So that's exactly what we expect. If we examine our input, we see 1, 2, 3, 4, 5 R's, and we should see the same thing in the next. Whoops, well, I skipped that column, but 1, 2, 3. This one correctly identifies that this is the only possible side. That's correct. So let's continue. The next one, it says there are no sides, which is true. And then the last one should also say there are no sides. There are no left sides possible there. I really do want to see the first or the second one rather, though. So that's wrong. Oh, no, that's right. No, that's wrong. This is this down here. Okay, so we're, and there we go. So there's our bug. We're running into issues at, at the ends of arrays. This method splits each chunk using adjacent elements, element before, element after, in the receiver enumerator. This method splits chunks between before and after, where the block returns false. The block is called with the length of the receiver minus 1. The resulting enumerator yields chunked elements as an array, so each method as follows. It's the same except splitting when the block. Slice 1, so this is doing... I don't think this solves our problem, though. And this chunk, can we use chunk? Chunk, each element is returned each element in the return array is a 2-element array consisting of a value returned by the block, an array chunk containing the element for which that value was returned, and all following elements for which the block returned the same value. No, I don't think we can use that. That's close. We're gonna have to implement our own thing, which is fine. But sadly, I think so we're gonna implement our own method on array, not on this, because we love refinements, and why not refine more things? So this is definitely operating on an array. Yes, it is. So we need some special chunk method. So that's a terrible name for this method, but it's kind of a thing that returns chunks, so I think that's funny, and because I have the sense of humor of an 8-year-old. We could even, if we're feeling really like writing terrible code, oh, come on, vomit emoji. Give me the vomit face. We're putting the vomit face in the code. You can't stop me. Maybe that should be another day, as we'll do an emoji solution. That should be something I do this year as well. So this needs to, we're going to build a result that's an array, and we're going to return it. And we are going to iterate over self. This will only work on plots. And if result is empty, or if result dot last dot plant does not equal plot dot plant, then we are going to shovel our plot into a new chunk of plots. And then we're going to return the result. Otherwise, do we do anything? Otherwise we shovel it into result.last. And then I guess we can do our little test here. So we can blow chunks. Whoops. That gives us the right results. Then we can blow chunks again. That's the right results, I think. Or was it? Or is that the one? This is the second column, the one that I care about being wrong. Ugh, come on, why am I not getting the right result? Why are you empty? There's nothing to the left. Okay. Step 1, make sure column is right. No. Column is not right. 1, 2, 3, 4, 5, blank, 6. We need 6 of these things. We only have 5 of them. Maybe we didn't even need this method. Maybe this was all a mistake. So that means our column logic is wrong somehow. Did I mix up inclusive and exclusive? I did, didn't I? There you go. So that's easy. We might remove our blow chunks then. Oh, I gotta get rid of that. That debugger. Actually, I can test it there. Why don't I just test that I fixed it? So column is right for that value, and column is correct for that value. And then we can test, first of all, the blow chunks gives us the right result, but we can also test that our original code does the right thing too. So it does as well. So sadly, we do not need blow chunks. It doesn't even do the right thing. So we'll call that a failed experiment. I didn't even implement the right logic. So thanks for coming out. So let's just break this up, then fix all of these. So these ones are initialize, and this one will want to be switched to X. Did I remove the debugger call? No, I didn't. Oh, and I have more debugger calls? Or did I just not hit save? It just did not hit save. Hey, that's in between our low and high answers. Oh, there we go. All right, so we did run into some iffy stuff, but it turned out most of my problems were just using the wrong types of ranges because I forgot which ones are which. I do strongly feel that 2 dots feels like it should have less things in it, and 3 dots should have more things in it. But I don't think we should change those around. That was fun. I have lots of work this week leading up, heading into Christmas, stuff to finish up, so I will probably not be streaming too much. I also have looked at the surf report, and it looks really good at least 2 of the days, so I'm prioritizing that. But probably like the 21st, 22nd, 23rd, maybe 24th, I will probably be streaming a lot to catch up on puzzles. I might also stream during the week. I might stream, I was going to say Friday, but I think Friday I'll go surfing. So I could conceivably stream Thursday. I don't know. We'll see what happens. As usual, follow along on Mastodon or Blue Sky if you want to keep up, and or just follow me on Twitch and get those go live notifications. Whatever works. Thanks, Marco, for coming out and helping. Huge help today. See y'all later.